Once again, here's a sign-in sheet. Please make sure to go on our campus page. Two things. In the web links section, we have the syllabus, other vital documents, some additional handouts, the eventual project. Remember, I told you there's this spending journal idea for September. This web link section, that second link takes us to YouTube and opens up a complete playlist of everything we've done so far. So if you're looking for, hey, he was talking about that, here's where you can find it. Additionally, if we go further down, eventually, once you've handed in an assignment and I've graded it, the key will be right there. Information regarding things for the exams will be in the one underneath it. All the way at the bottom is everything I wrote under this camera. So I wrote all that stuff on Wednesday. I scanned it in. Here it is in PDF. Eventually. With everything we did, all the examples, all of it worked out all the way through. If you're looking, oh, I didn't get quite that thing, it's here. You don't have to be just recording during this class. I'm doing that. Your goal is to process. So you're welcome to take good notes, or at least half-ass notes, and then listen to this again and write up better ones and make this yours. So we were talking about turning words into symbols, doing things with those symbols. Remember that most of the world works in words. Nobody speaks in equations outside of specific lectures or discussions about mathematics. You will find very few people walking up and introducing themselves to that next plus working. No, it doesn't happen. But you will have people talking about money, about sales, about tickets. I have a sellout crowd in my 1,200-seat auditorium. Yes, sir. Oh, behind you. Gross receipts are $9,000. General admission is $6 a ticket. And reserved seats are 10. How many general admission tickets did we sell? Now, a lot of problems have more, a lot of failures have more categories of tickets than just general admission reserved seats. You ask Charlotte Hampton, you've got those two. That's it. That's what they sell. General admission, lawn seats, and reserved seating. Absolutely. No. You can, however you want to do it. The question becomes, from this information, what sort of algebraic expression can I write that will allow me to figure out how many general admission tickets? Okay. Again, just like we were thinking about the integers on Wednesday, I need to know what the words mean and how I'm going to assign abstract concepts here. I'm asking specifically about the general admission tickets, not the reserved tickets, right? So really, that's the thing I don't know that I want to find out about. That's my area. That's the letter I want to assign to them. By the way, you can pick any letter. We used S for an integer last time. We can use anything you want. I'm talking about general admission tickets. Maybe it use G, maybe I use T. It doesn't matter. You don't have to use X. Everything does not have to be X. Oh, history. Do you know why we use X? There are two different stories about why we use X. I'm really going to blame one Frenchman who wrote a book and said, I want to use letters at the end of the alphabet for things I don't know. But the real concept can be thought of in one of two different ways. I don't know if either of these stories are true, but they're good stories. The majority of written work in mathematics was in Rome. And in 500 AD, what happens in Rome? Sorry? The sack of Rome. Rome goes away. As a matter of fact, during the sack of Rome, the emperor, Democritus, I believe, declares the universities to be hotbeds of what is the most woke thing at the time. Christianity is the Roman Catholic religion, right? And all of these universities are full of books dedicated to the Greek and Roman gods, these heretics. How dare they? They closed the universities, declaring all of these books to be heresy. And so the people run. They take their books and they scatter. And the majority of those books head away from Greco-Roman and Western, what we consider Western culture, and move to the Islamic Empire, the Persian Empire. And they get translated into Arabic. And that's why all of these words start with AL, algebra. It's an Arabic word, the method, aliyah. So all of these things go away, they get translated into Arabic. The Persian Empire is huge. Covers all the way to Portugal and Spain. The Moors, Robin Hood, the Crusades, the Moors are in Portugal and Spain, and England is fighting them to prevent the spread of the Persian Republic. Arabic books have to be translated into these other languages. The Spanish alphabet, Portuguese alphabet, is the Latin alphabet, not the Islamic alphabet, not the Persian alphabet, not any of the different varieties of Islamic languages you want to speak, Arabic languages you want to speak. It's the Latin alphabet. Anybody here speak Spanish? Take the foreign language. There's a useless letter in Spanish. It's part of the Latin alphabet and it never gets pronounced. Dígame, Javier. Dígame, Javier. Javier. ¿Cómo se escribe? Oh, a J. You spell Javier, you spell it with a J. If you spell Javier in English, you spell this letter. Xavier. Javier. It's not pronounced in Spanish. It's not used in any Moorish Spanish. Why not this thing I keep trying to solve for, which in Arabic is shocking? This thing I want to know. Why not give it a symbol that I don't use anyway? I have no idea if that's the real story or not. Sounds good.
You're not always, but people are always saying that the math changed during like the way back then till the now. Have you personally seen change in math happening currently in this day? that people are now, like, what is it, the biggest change in math that was like maybe like 5 years ago or 10 years ago?
The biggest change is the way in which we write mathematical arguments. Most of what we are doing is formulaic. I have this formula, I know the rules by which to manipulate this formula. But when you get beyond arithmetic and algebraic pieces of mathematics, you get the formal logic of mathematics. And the formal logic of mathematics is something we've gotten really good at turning into computer code. The AI revolution has really redefined the way thinking about mathematics. A lot of problems that have been unsolved for 200 or 300 years have been solved in the past 3 months because they've written verification engines in computing software. And they're just, okay, I think this is true. Let's do 180,000 cases. That would take me the rest of my life. It took the leading programming system an hour and a half. And since I was able to say these 180,000 cases cover every possibility, it must be true. Computing has been the biggest change in mathematics. But the way we think mathematically now isn't the way we thought mathematically then. I have all these Arabic books. 1400s, 1200, 1400. We have the Middle Ages. Middle Ages end with the Renaissance. Renaissance is in Italy. All roads lead to Rome again. So we go to Italy and we translate these books back into Italian and Latin and Greek. As a matter of fact, the first modern book not written in Latin and Greek is written in Italian for mathematics. A young person's mathematical compendium is written by Maria Gaetana Agnesi in Italy in the 1400s. The school that teaches this Arabic method with their new numbers and the new numerals that we're using and this method of solving things, this representation, they're looking for the thing, right? That's what shy is, that's the Arabic, that's what the X is supposed to be, it's the thing we're looking for. They want to find the thing. Okay, who speaks Italian? I'm in it, that's very good. In Italian, thing is cosa. C-O-S. But it's the thing. C'è cosa. In Spanish, it's very close to both Romance languages. They derive and say, hey, but c'è cosa. Again, Italian at that point is written with the Latin alphabet. I'm going to write c'è cosa in Latin, in Italian. C'è cosa. What's it start with? An X, damn it! If I have to keep writing the thing, I'll abbreviate the thing. You use whatever letter you want. I don't know if that story is true either, but I do know that the Italian school was called the Casas. Thing finders. Okay, I'm looking for general tickets. So I'm going to make myself a note here. Let G represent the number of general admission tickets. Now let's think about what I'm trying to find. I'm trying to figure out what this number is. G is the thing I'm trying to find this time. And what I know is that each of these tickets gave me $6. So if I think about the part of the gross receipt, the money I got in from these tickets, it'll be whatever this number is times 6. The total amount of money I should have is the money I get from the general admission tickets, the money from G, and the money I get from reserve tickets, right? Okay. It was written up there. I just scrolled it off the top of the page. How much money did I have total? $9,000. Money per ticket times the number of tickets. I had $6 for each ticket in the general admission aisle. And I had the other tickets. How much was each of the other tickets? Say again? $10. How many of those do I have? I don't have a letter for that. I need something else to tell me how many reserved tickets there were. Let me go back up and look at the other information I have. You were going to say something. I'm waiting.
R is reserved, but it's gonna have tickets, so you wouldn't really use it.
I could use whatever I want for it, right? I could use another symbol. I could use both letters together, RT. But my goal here is to only end up with one letter if I can. I don't want to have multiple letters floating around like I did with the integer and the next one. I made them relate to each other. So how can I relate the number of reserved tickets to the number of general tickets? That would be the total number of tickets I sold, right? All the tickets are either reserved tickets or general tickets.
Yes, I put the total amount of seats that we have, which was 12,000 negative minus G. Put it in parentheses.
There are only 1,200 seats. Anybody who doesn't have a general ticket has to have one of the reserve tickets. So the total tickets are 1,200, but I don't care about the general people. I already did that. I only care about the other ones. And that would be exactly what goes in that set of parentheses. There are 1,200 total tickets, but I've already spoken for the general admission one. So there's a relationship with that R that you wanted to use. I could actually think of this as two separate equations that we kind of glued together. Let me write it kind of like that. I could say 9,000 is 6 for the generals and 10 for the reserved, and that the total number of general and the total number of reserved tickets must be 1,200. That's each of the sentences we use together, isn't it? There are only 1,200 seats, and they only come in 2 flavors. And this is the money we got from each one. If I rearrange this expression, move the G to the other side, this was the big deal in algebra. Balancing and reconciling. If I want to get the G off of the left side, I need to subtract it. What I do on the left, I need to do on the right. Then I can take this whole thing and shove it in there. And that's exactly going to give me this expression. Yes, ma'am.
Does it not check so R in the end will become 1,200 people anyways?
But look at what the question was asked. The question asked me, how many general tickets did I sell? Now, in the long run, I'm really happy we made that print. But if I have an auditor come through my theater business and look at the receipts for that night, and I say, hey, we sold 100 general admission tickets and the 900 reserved, I should have way more money. Where's the rest of the money? Who's stealing my money? I need to be able to balance my books. And that's a way to check. Now, I have not actually answered the question. That's okay. I don't have to answer the question. Now, ask for an algebraic expression that represents it. But now I could say, in this, can we figure out what G is? How does one go about solving such an expression? Well, now I'm going to play the algebra game the same way. I'm going to do what I can with the rules I know. So let me jump back from this other way of getting the expression. And let me start with this expression again. My goal is now to know, okay, what is the actual value of G? How do I figure out how many tickets I sold? How many general admission tickets I sold? Because that's what G is. These are the rules we talked about on Wednesday. I want to take that thing on the right and simplify it as much as I can.
You're gonna take the 10 times the 1200 and 10.
Here's a property we do algebraically. If I'm multiplying by something in parentheses, I can distribute over that set of parentheses. So I take this 10, multiply it by the 1200, and multiply it by the G. And when I multiply a positive thing by a negative thing, the result is negative. So that's a minus 10G as opposed to just 10G. So far, so good? Okay. Wait a minute. I have two different sets of G's. Let's rearrange. I'm going to take these two items and swap their locations. Again, if I'm adding or subtracting, the best part about adding and subtracting, when I do stuff from left to right, as long as I keep the signs associated with the pieces, I can do it in either order. 5 plus 7 is the same as 7 plus 5. The 5 minus 7 isn't the same as 7 minus 5. But negative 7 plus 5. That works. So keeping the minus with the 10 is the important setup here. Formal name for this sort of crap is commuting. I'm commuting the commutative property. I'm moving around. Okay. 6, okay, I have a G is 2 G's, right? Let's combine those. 6 G's take away 10 G's.
There'd be a way to just relabel it, just in case.
Relabel what?
Cheese.
What do you mean by relabel?
I'm a little sass to like a G with an accent.
Well, but if I do that, I've changed the thing, right? I really want to know what the value of this thing is, so I don't think I want to change it. But I can think of like I've got 6 copies of G over there and I've got 10 copies of G over there. I want to put those together, right? So I'm really just counting copies at this point. How do I combine those? Why? I'm doing the parentheses game this time, like we did here, but I'm doing it backwards. I'm going to take the G here and pull it out from the 6 and the 10. And yes, 6 take away 10 gives me a negative number. It gives me a -4. So that's absolutely correct. I now only have one G. This is good. Because eventually my goal is to get G all alone, but I only have one of them, so I'm happier about it. I gotta move some more crap around. Now you get to play. What were you just doing with your hands?
Switched it.
I want to move the 9,000 that's over there on the left to the right. I want to take the 4G that's on the right and move it to the left. I can do those as separate steps, or I can do them at the same time. But the 4G on the left, sorry, on the right at the moment is negative. To get rid of it, I need to add. Yes? So I'm going to say to myself, what I'm really going to do is I'm going to add 4G. But if I add it on one side, I have to add it on the other. At the same time, it's not required that you do this at the same time. You can do this separately. I'm going to take the 9,000 and subtract it. And I'm going to do the same thing over here. That little squiggle there is just to remind me that, hey, these are two separate sides. What do I end up with on the left?
4G.
4G. The 9,000s cancel each other out, but I added this 4G here. What do I end up with on the right? $3,000. 12 minus 9 is 3, and I keep all the zeros. And the 4G and the negative 4G, they're gone. They canceled each other out. My goal is to get G all alone. It's being multiplied. What undoes multiplying? Dividing. So I'm going to divide. I divide both sides by 4. What's 3,000 divided by 4? I have a calculator for a reason. What is 3,000 divided by 750? I am old as dirt. 4 into 3,000. Long division. Does 4 go into 3? No. But 4 can go into 30. What is the smallest multiple of 4 that is smaller, the largest multiple of 4 that is still smaller than 30? Which is 7 of them. So I put a 7 here and I write a 28 here. And I subtract. 30 minus 28 is 2. Bring down the other numbers. Can 4 go into 2? Nope. But 4 can go into 20. How many 4s make up 20? 5 times 4 is 20. Subtract, bring down the other number. Oh! There are no 4s in 0. G is 750. How many reserve tickets did I sell?
450 reserve tickets.
How did you get that number?
I subtracted total number of seats with the 750.
If this is the gross, the number of reserved seats was here. And now I can check my books, right? So, if I made $6 from each of these, and I made $10 from each of these, what's 750 times 6? Say again? Aha. And 450 times 10 is also 4,500. And that's how much money I said I was going to have. It's worked, master. It's worked. I like this. This is the sort of completely, totally 100% rig problem. That people have been doing math for 4,000 years. I have clay tablets written in cuneiform from Mesopotamia, talking about the amount of wheat in a square field of a given size and the amount of wheat culled from a different square field of a different size. I know the total of both areas, and I know the total of the wheat production. How big is each field? That question is 4,000 years old, if not older. That's it. Literally, that's this. It didn't get turned into symbols until much later. The cuneiform tablet is all in words, but it's the exact same. And the units don't make any sense. I don't know what a burr of grain is or a cooler of area. But that's just because they use my big measurements. I was not in this. That's not true. Technically, I visited Israel in the 80s, and that technically was part, so never mind. Yes, yes, ma'am. Then you don't have to do any of that part.
I just wanted to double check if you wanted to see that.
We're going to talk more about solving as we go on, and look at the other methods. I wanted to say, I didn't ask the question. I really shouldn't answer the question. It just says, give me the expression, don't solve it, do that function. More questions. Yes, ma'am. Neither. Technically, this homework is due Monday. Because I hadn't finished it on Wednesday, it didn't make sense to maybe turn it in now. I wanted to do more of these. I wanted you to do some of them while we were here. So I want us, I'm going to do one more example now of translating English to geek, and then I want you to take a crack at the homework problem and go, if you've already done most of them, please go back and take another look. I will collect it Monday starting. You can also get to the calendar, which shows all of your classes, all of your assignment due dates there. Back in our class specifically, in Make Money Matter, over there on the right-hand side, it shows you the list of the associated due dates and what's coming. And I even tried to make sure that I put the beginning of the class time. Okay. Again, this is a blatantly rigged problem. Okay. I'm not going to solve it. I'm just going to set it up. A collection of nickels, dimes, and quarters is worth $1.65. There are 2 more dimes than nickels, but only 1 more quarter than the number of nickels. How many of each coin do I have? Okay. Three different types of coins. How about N, D, and Q? Does that make sense? Nickels, dimes, and quarters. You could use any letters you want. I figured I'd make variables that kind of related to what's going on. Again, the dark ages. I learned to program a computer. You were told to use very short names for variables in your programs, but you should make the name of the variable related to the thing it was describing. If you had a counter, you named it counter. If you had more than one counter, you named first counter or A counter and B counter, or you named it for the clock, like AM counter, or you named it. So you had that, somehow you knew when you looked at that name what the hell that was supposed to be. N, D, and Q seem to make sense for me here. So I'm going to say N is my number of nickels, D my number of dimes, and Q my number of quarters. Now, I know the total value of all the coins. That means I need to know the value for each coin. And I need to do that in dollars because of the way this total is written. Or I could change everything to cents, right? A nickel is 5 cents or 0.05 of a dollar. Your choice, dollars or cents. Which one do you want? I hear cents there. I hear dollars there. Let's do it both ways. Right? 5 cents or 0.05 a dollar, 10 cents, $0.10, 25 cents or $0.25. The total value of my coins is $1.65. So if I did everything in dollars, it would be 0.05 times the number of nickels. 0.05 of a dollar for each nickel, plus 0.10 for each dime, plus 0.25 for each quarter, equals to 1.65. That's in dollars. I'll put dollars up here so I remember that's the dollars side. If I do it in cents, it's 5 cents for each nickel, and 10 cents for each dime, and 25 cents for each quarter, and 165 cents for the total value. All I did was move the decimal places over by 2 from one side to the other, because 1 penny is 1/100th of a dollar. Okay. This is great, but it doesn't help me answer the question, how many of each coin do I have? Because I've only used the first sentence so far. What's the second sentence tell me? It tells me about the coins related to each other in terms of their count. Okay. So I need to know, I can now relate the number of dimes to the number of nickels and the number of quarters to the number of nickels. Well, the number of nickels is N, and the number of dimes is D. And there are 2 more dimes than nickels. So the number of dimes is 2 more than the number of nickels. And there's only 1 more quarter. 1 more quarter. No, wrong way. The number of quarters is 1 more than the number of nickels. By the way, those expressions go on both sides here. Okay. If I were going to try and solve this, I would want everything in 1 letter, just like we did with our tickets. What letter do you think I should use? D, Q, or N? Because I can relate everything to the number of nickels. So here, I can take this expression and put it in for the D. I can take this expression and put it in for the Q. And regardless of which side of the game I'm working on, I now have an expression all in 1 letter. Once I know how many nickels I have, you tell me how many dimes I have. We only had 2 types of nickels. This time I had 3 types of coins. Ah! I got lucky. Everything could be related to 1 fundamental number. That allowed me to write a single expression, an equation that I can solve. Whew. Almost always, the hardest part of a given problem is going, what the hell does this paragraph mean in extractable information that I can take it from English to Greek symbols? Almost all of the questions you are going to be asked to give me on Monday are in this vein. Simplify an expression, solving a number, rarely. Most of the time, if you're calculating a number, we're doing it like we did on Wednesday, where we're taking some big expression with all numbers and jamming it down to be 1 number. You shouldn't be solving these in this chapter. We will be solving them. Questions? I got about 8 or 9 minutes left in class. You should take a crack at some of these. The assignment for this section is right here. Is on page 33 in Sean's outline. So if you've got your book on the computer in front of you, you should open it up and find page 33 and take a crack at it if you've already done it. Read through the again. Double check yourself. I cannot tell you the number of times I've gone back to a page before I've done. Not what I missed. Or that I made a copy error. The single most stupid thing I have done in years was to make an assumption about something in the paper I was writing, and the 90 pages of work with an error on page 6. That was my PhD thesis. That was 18 months for those 94 pages. I had to throw it all out. Start over. I did eventually finish it, but boy, that was a hell of 3 months for summer. 4 months. I did some of it in spring. Anyhow, take the last few minutes of class. If you've got questions, this is where we should be talking about this is where we should be asking me things, because unless you come to my office hours this afternoon at 3 o'clock, any question you want to ask me has to be sent via email. Okay. Go to, start cranking on this. If you want to get at the book through Canvas, in the upper left here, it says course materials. When you click on that, a new tab opens, and there are our 2 textbooks. Now, the best part is that in the Funimatics book, there are actual live web links to some of that section. So some of those things will be made available to you to click on to go through.
Right, he's out for this issue, so I will involve.
Okay, so, yeah, let me pull it up. Okay, so on page 33, which is where our problem list says to go in the Shams outline, read now. Come on, open up. So, tick, tick, tick. When I go to page 33, that's a list of supplementary problems, right? I only need you to look at the problems in that section titled Problems to Turn In on this page. That's the rightmost column. You don't have to do all the rest. Ones from 1 to 49, you can do as many or as few of those as you like. The ones I'm looking for are specifically 25, 28, 31. Those are the ones I want you to write up and hand in. No, these are here in the assigned homework PDF right here. That's this page. So I go down here, the first question on this list is 25. And that's the problem after. Hey, look, it says translate this expression and identify. Okay, so that's asking you to do this. Turn English into. Now, the reason for that at this point, 37, 43. Oh, so almost all of what I'm asking you to do is translate. Please note, I want to see your thinking on a piece of paper. So if you're saying to myself, well, I thought I would write it all down so that I don't have to try and read your mind. I do want to see the answer. But if you're saying, oh, well, I tried this, then I did, put it all on. Much as you can, shake it out of your brain onto the paper so that I know where you were coming from. Questions? I will see you all on Monday. Have a lovely weekend. If I see you in office hours, great. If not, if you have questions, send me email.